So our second speaker today here is Lana Mineh, a PhD student at the Quantum Engineering Centre for Doctoral Training, and is pursuing this PhD alongside the quantum startup Phasecraft. Lana is therefore well suited to talk to us today about undertaking a PhD with industry. So Lana, if you're here and ready to go, feel free to take it away.
Yes, can you see that?
Yep, all good.
Okay. Yeah, so thanks for the introduction. My name's Lana, and I'm here to talk about my personal experience undertaking a PhD with a quantum startup. So just a bit about me. I'm a final year PhD student at the Quantum Engineering Centre for Doctoral Training, so the same group that are organising this conference, and Phasecraft, which is a quantum startup. So I've been working with Phasecraft for almost 3 years now, so kind of the research part of my PhD. And Phasecraft is a quantum software company whose goal is to get the most out of near-term quantum computing hardware. So I'll talk a bit more about what Phasecraft does in a bit. First, I'll say a bit more about my background. So my route to the PhD could be considered to be fairly traditional. I started my undergrad degree straight after A-levels. I did a 4-year integrated master's in mathematics at Imperial College London, and I graduated in 2017. During this time, my master's project involved quantum information. I found the topic really interesting. I wanted to learn more. So I applied for quantum CDTs and got accepted at the one at Bristol. So my route was fairly traditional to the PhD, but the PhD itself has definitely not been traditional thanks to the CDT and Phasecraft. So a bit more about the CDT. So it's a 4-year PhD course. 1 year is a training year, kind of like a master's course, and there's 3 years is just like the traditional PhD research. So you start in the first year in a cohort of about 10 or 12 PhD students, and the aim of the first year is to get kind of a broad overview of topics in quantum engineering and figure out really what you want to do. So you kind of attend various courses such as quantum info, quantum optics, and so on. There's lots of invited speakers who talk about their expertise in aspects of quantum engineering. We do experiments in a group. We have a whole cohort project. And probably most importantly to the PhD, we do kind of 2-3 month long projects to basically just figure out really what we're most interested in. So it was through one of these projects I got involved with Phasecraft. Some highlights of the CDT. The CDT has a lot of connections with industry. We visited a couple of companies here in the UK, but the highlight was going to America and visiting Rigetti and CiQ. Throughout the other years of the PhD, you do stay involved with the CDT. I was part of the group that organised Careers in Quantum last year. We were lucky to get it in before the pandemic. So that's another reason why it's great to talk here today and see the event carry on. The CDT is also really involved in outreach, going to festivals, talking to school kids. I've kind of been involved in a few women in quantum events. Okay, so on to how I got involved with Phasecraft. So like I was saying, I got involved through one of these short CDT projects. So as an aside, CDTs tend to have links with industry, so it's always a good place to get involved with industry. I did a project with Ashley Montanaro at the University of Bristol, and he was founding Phasecraft at the time with Toby Qubit and John Morton, who are at UCL. My project was on applying the variational quantum eigensolver to solve the Hubbard model. I'll talk a bit about what this means in a minute. Basically, I really enjoyed doing the project. It seemed like a good fit, and it just kind of naturally turned into my PhD. So I'll talk a bit about my PhD briefly. So the Hubbard model is a model used in condensed matter physics. It's a simplified lattice model of interacting particles in a metal. So you represent like the metal as like a grid of sites, and each site can be occupied by an up and a down electron. The two kind of types of interactions you can have is electrons can hop from one site to a neighboring site, and that's called a hopping term. And there's also an on-site interaction when two electrons kind of share the same grid site, and some kind of interactions happens between these two, and that's called an on-site term. So despite being fairly simple, it allows us to investigate how the interactions between electrons change the properties of metal, so making it insulating, magnetic, or superconducting, for example. And the 2D model has remained unsolved despite many years of effort. So the hope is that this is a quantum system. Maybe a quantum computer could help model this and help solve the problem. So the variational quantum eigensolver is one of these algorithms. It's a hybrid quantum classical algorithm. So these are quite suitable for the noisy intermediate scale quantum era. So this is the era we're in now. You have a relatively low number of qubits, and they're all kind of really noisy. And you just kind of want to see how, what can you do with this really noisy, really terrible quantum computer? So the aim of this algorithm, the VQE, is to find the ground state of a given Hamiltonian. And the way it works is that you basically run almost like a random circuit on the quantum computer. You measure the expectation value according to the Hamiltonian you're trying to find the ground state of. You pass this kind of expectation value or like energy into the classical computer, which runs a classical optimization routine, which gives you like another set of parameters for this random circuit. And you kind of just keep looping over and over again until you've reached a minimum. And when you've reached a minimum of the energy, you kind of hope you've prepared the ground state of this Hamiltonian. And then you can probe for the ground state and figure out properties of it. So there's lots of aspects of the VQE algorithm that have to be tailored to the Hubbard model. For example, using any old random circuit is not good. So what's the best circuit to use? What's the best classical optimization algorithm to use, and so on. So that was kind of the topic of my short project in the first year and a half of my PhD. And it resulted in a publication with a couple of other members of Phasecraft. Okay, so like I said, Phasecraft's goal is to get the most out of near-term quantum computing hardware. And this is also just the topic I'm most interested in. So it kind of joining Phasecraft was like a good fit for me. The company itself is split between Bristol and London. I think the Bristol team is more focused on software, whereas the London team are more focused on physics. But I guess as the company's grown, it's kind of that line has blurred a bit. So a couple of examples of projects that Phasecraft is involved with. They're involved with a battery modeling project, a project on error mitigation. So this is kind of getting the noisy quantum computers to behave how you want them to behave. And they're also part of a project that will deliver a Rigetti quantum computer in the UK. But yeah, if you want to hear more about these projects, tune into Stagia's talk on Friday to learn more. So when I joined Phasecraft, it was kind of right at the beginning. So it was kind of a handful of PhD students and the founders. So it's something that's, I've had quite a unique insight into is how the company has grown over the past couple of years. There's now like more than 15 employees split between Bristol and London. Our Bristol offices are in somewhere called the Quantum Technology Innovation Centre. We share the space with a couple of other quantum startups, so it's quite a nice place to be. Yeah, and yes. So kind of onto just some advantages of doing an industry PhD. So you can really get an insight into how companies work. For me, that's coming like seeing how the startup has grown over the past couple of years. If you join like a bigger company, that would take another form. It's a really good opportunity to experience both academia and industry during the PhD, because you do stay connected to the academic group you're originally part of. And it really gives you kind of, you get kind of a nice overview of kind of what you would want to do in the future after the PhD. Kind of like a secondment or an internship, I do think it does improve your employability, certainly within the organization itself, who's spent so long training you. And it looks good on CV. You get to really work with a group of people who share the same goals. With an academic group, there's like kind of there's kind of a broader background. A lot of people are working on a lot of different things, but kind of everyone, at least at Phasecraft, has kind of the same kind of goal. So it's interesting to work in kind of like a really quite focused group. There's lots of opportunities to collaborate within the company and with its partners. In that way, you can kind of make connections and network with other industries. So I think that's really quite valuable. And contribution to PhD funding. So I'm part funded by Phasecraft, but I know of people who are doing industrial PhDs which are fully funded. So that's kind of the way they've done the whole PhD, or been able to do the PhD. So I wanted to kind of be fair and talk about some of the downsides possibly of doing an industrial PhD. So companies might want to get your intellectual property rights. What this kind of means in practice is that if you do your PhD and you come up with something at the end, you then can't go off and make a company yourself to profit off it. The company that you've done the PhD with will get the rights to all that work. So this might be a deal breaker for some people, and for some people it doesn't really matter. You might have to sign like a non-disclosure agreement. This can make it harder to talk about certain aspects of your work at conferences and things like that. So I said collaborations were an upside, but on the flip side, collaborations outside of the company and its partners could be a bit more difficult than a standard PhD. So that's also worth bearing in mind. You may have less control over the subject matter of your PhD. I've been quite fortunate at Phasecraft and been able to work on pretty much what I wanted to do, which has been really great. But if you completely decide to change the topic of your PhD, that might be a problem. But yeah, these are all kind of very situation and company specific. I just wanted to give kind of a rough idea. So that's kind of about Phasecraft and just general kind of industrial PhDs. what does my actual day-to-day look like? Well, in practice, it's really not too different from a typical PhD student. Any PhD student will tell you that there's really no set routine. You just kind of work on what you're doing at the moment. So like I said, apart from weekly meetings, you could be doing something completely different month to month. I have weekly meetings with the whole team at Phasecraft. We have internal talks. I kind of go to the talks in at my academic group as well. So there's a lot of variety there. I've personally spent a lot of my PhD doing numerical simulations and coding, because that's what I enjoy. I've learned C++ over the past couple of years, so I think that's quite a valuable skill. There's the usual presentations, conferences and outreach events. I talked a bit about that earlier with the CDT. It's the same with in industry. You can just get sent out to talk at a conference about the company. What I'm currently doing is a lot of writing. I'm writing up a paper to do with the work I've done over the past year, and I'm in the last year, so I'll soon be writing my thesis. I'm just going to finish with a little note about internships and jobs at Phasecraft. So I think internships are a really great way of seeing what it's like working for a company, and figuring out if you do want to work there in the future. Interns work on a short research project, so between a couple of weeks and a couple of months, of relevance to a part of Phasecraft's business. So we had 2 summer interns last year. We'll have 6 this year, and we'll likely take on some more next year as well. And Phasecraft is just continually hiring, looking for postdoc level people, kind of with expertise in either quantum information or more on the physics side with condensed matter or material science. But yeah, if you find any of this interesting, please get in touch at careers@phasecraft.io. Yeah, thanks for listening. Are there any questions?
Awesome. Thank you very much, Lana. That was a fantastic talk. Very interesting. We have a few questions in the Q&A. Potentially I could start with one from us. How has the industrial interaction changed your outlook or your attitude towards your PhD?
Oh, that's a good question. Yeah, I think it's changed. So right at the start, it was kind of very much, I found it was quite similar to just doing a standard PhD. And it's definitely changed while it's grown. I've kind of I guess kind of grown closer to kind of doing stuff on the Phasecraft side, and I've kind of gone a bit more distance from just the academia. Yeah, I think I kind of prefer the way kind of it works in companies, like seeing kind of both aspects. But yeah, because of the CDT, I've also stayed very connected to academia. Yeah, I don't know. I can't really compare my experience to just doing like a standard academic PhD. Because everything I've done has been so linked to Phasecraft from the beginning. So.
Definitely. It's a very unique perspective. So yeah, no, thanks for coming and talking about it today. A question from Sophia Leeper. Does Phasecraft take on undergraduates for internships? Do you know?
I think for the most part, Phasecraft have taken on PhD students or master students. But I think we have had lots of applications from undergrad students. So I think just if you're interested, get in touch. There might always be like something that you could be, if you've done a certain course or a certain project, that you can help out with Phasecraft. So yeah.
Definitely, thanks. And I guess a follow-up question from Taufik. Does Phasecraft accept interns from other countries, or is it mostly just from the UK?
We do accept interns from other countries, yes.
Okay, so is that like a remote working type deal that you guys have
Um,
going?
I think actually there's some people coming over, like flying over to the UK this summer. So it can be remote and it can also be in person, I think.
Awesome, thanks. We've got a question from Abiska. It says, "Hey Lana, I'm a high school graduate and want to pursue a career in quantum computing. What major do you suggest as an undergraduate?"
Made. Um, well, I mean, I did a maths degree. I think anything between like maths, computing, physics, any of that, I think is good. Like kind of everyone's kind of got here. Everyone at Phasecraft kind of has a range of backgrounds. So any of those sciences, I think, is just, I think, fine.
Fair, yeah, it's definitely a very interdisciplinary type subject that we're in.
Yeah, exactly. Yeah, I think that's what drew me to quantum in the first place. That it's kind of the connection of all these like sciences.
Awesome. And someone has asked a question. So why have you chosen an industrial PhD over a standard academic one? I guess maybe what contributed to that decision to make that move?
Um, yeah, it kind of just like I said, it just kind of happened through doing the project. I didn't really intend to do an industrial PhD. I mean, I didn't really know that was a thing. Um, it was more of a matter of picking the project I was most interested in at the end of the first year of the CDT, rather than kind of thinking about joining a company or anything.
So would you say, like, I guess joining the CDT gave you that kind of unique perspective to be able to make that move?
Yes, yes, certainly.
Awesome. And actually, kind of a related question from Brandon. Do you have any advice from your experience in applying to PhDs like the Bristol CDT?
Just general advice.
Yeah, I guess, yeah, like application process, either what to do to
Um,
develop skills for it, or yeah, like how to work towards it.
Everyone kind of also at the CDT has a range of backgrounds. There's people with, physics degree, maths degree, engineering. So I think just kind of make your strengths kind of clear in the application. Showing that you're a good team worker is important, especially for CDTs. I mean, we've had people with no experience in quantum joining the CDT, so it's really just about kind of showing that you can make the effort to kind of learn everything in during the first year.
Definitely, no, thank you. And another question from someone, if that's all right,
Yep.
said, if I'm in my bachelor's now, what should be the correct path to enter the quantum industry? Which I guess is something we kind of just covered, but should they get a master's and then a PhD? Or just a PhD if that's an option, if there are any other alternatives?
I mean, from what I've seen, there is no correct path. It's just, there's people who've done PhDs in completely different subjects who've ended up in the quantum industry. I think just do what makes sense to you. I mean, I chose the CDT because I felt I kind of wanted a broader background before embarking on the PhD, because I'd just come from maths. I hadn't really done the physics side. So if you think you kind of want a bit more, I guess, like practice and learning before you embark on a PhD, something like a CDT or a master's would be a good idea. But yeah, you could just start a PhD if you wanted as well.
Thanks, Lana. I've got a couple more. So there's one from Thomas Clark, which takes a move towards the science side of things. It says, thanks for your presentation. Good to hear your perspective. Out of curiosity, does VQE run well on DWave's quantum annealers?
I don't really know that question. I don't really. I mean, I don't think anyone's tried VQE. It might have tried like a similar algorithm like QAOA on DWave. But yeah, VQE is mostly just done on the more standard superconducting quantum computers. Yeah, that's an interesting question.
Awesome. Fair enough. Thanks. And we got a question from Tawfiq. They're saying they are curious of how many qubits you need to implement VQE to solve the eigenstate of a 2D Hubbard model of a given size. And do you think that this can still be improved, or is this analytically optimal?
So if you wanted to say solve a 50 site Hubbard model, you'd need 100 qubits. Because on each site you can have an up and a down electron, so you kind of need a qubit keep of each of that on the sites. There are methods to kind of compress this size, but it kind of works in just very specific circumstances. So in general, it's just like double the number of qubits as you have sites.
Awesome, thank you very much. And then maybe we've got time for, well, one more from us. Has working for a company affected the support structure that you have compared to like a typical PhD at all?
I think it's like it's almost increased it. So I have both like the support of like, you know, my supervisor and the company, and also I've got the CDT as well, and just general like, you know, the maths department I'm part of. So it's kind of added an extra aspect. And I'm always able to go to the CDT for anything I need as well, which is good. Yeah.
Definitely nice to have a range of options there.
Yeah.
And maybe a short one from Shruti. How do you stay motivated during your PhD? Maybe relevant to all of us. But,
Yeah. Well, I mean, you kind of go through waves of being motivated and not being motivated. I think that's just part of a PhD. It's harder to stay motivated when you're, say, writing a paper versus like kind of in the midst of like, you know, some really interesting research. I kind of prefer to just treat it as like a, you know, 9-to-5 job. You know, I sit down, I do the work for the day, and then relax. So I think that's kind of my way of doing it.
Yeah, no, that's yeah, very relatable. There's one from Shobit as well. Says, thank you for your presentation. I would like to know at Phasecraft, only with people with software skills eligible, or one with a PhD having experimental skills in the field, for example, spintronics, which is closely related to the field with quantum computing. Is that also kind of some degree of eligibility there?
Yeah, I would say yes. And if you're interested, just get in touch and see, you know, if it works. You know, anyone kind of with an experience in quantum is very valuable. And especially as like we're kind of getting towards like more running stuff on quantum computers, kind of someone knowing about like, say, the kind of the challenges, you know, and actually constructing these things, it would be very useful to the company. So yeah, any experiences is welcome, I think.
Awesome. And then one from Snigdha Chowdhury. What kind of requirement do you need to apply for internships? Is there like a sort of barrier, like a minimum barrier that you guys look for, or if you know that sort of thing?
I don't know about a barrier. I would suggest you check on the website. I think there was an advert for internships a while ago, and just see what it says. Yeah, I mean, kind of anyone's considered, you know, if they have like a certain amount of experience or just interest in the topic. But yeah, I would say either get in touch or we can chat more during a networking session or something. Yeah.
Awesome. And then there's one last one, so actually we can get through all of these. There's one from Abhijit, which is, how can one get into quantum from software development with 5 years experience, as potentially a master's is not possible, which maybe relates to what you were saying earlier about the interdisciplinariness of the field. But
I mean, I think if you look at just, you know, job adverts, there are companies like looking for just software engineers, as they're kind of developing, you know, more you know, software packages and you know, tools and things like that. So maybe finding like one of those jobs would be kind of like a foot in the door, and then kind of you can learn more about quantum while you're in the job. But yeah, or either that or some kind of internship maybe. Yeah.
Awesome. No, thank you very much, Lana, and thank you for answering so many of our attendees' questions. It's probably Good for now. If there are any remaining questions, please do post them in the appropriate Slack channel for this talk. But thank you again, Lana, for your time.